All right, properties of logarithms. We're going to do section 8.5. This is the inverse of the properties of exponents that we had done before. You will want to write these down, either on a little sticky note or something. You will want to write them down, okay? The last lesson we learned that if we had log A equals B, what was the invisible base on that one?
E.
Pardon me?
E.
No, the invisible base on this one. If it just says log, what's the little
10.
invisible thing down there? 10. So this is 10 to the what equals what?
10
10 to
to the B equals A.
the B equals A, correct? All right. What if I have just a plain ln? It's in little invisible base?
E.
E, so that's E to the what equals what?
E to the B equals A.
E to the B equals A. Okay, so this is what we did last time. But if I didn't have invisible, if I had a letter there, like C, this is C to the what equals what?
B.
C to the B equals A, okay? There's something that we need to always remember. What happened, we talked about this last lesson also, what if I have log base C? What happens to this log C? What does it kind of become?
1.
It becomes a 1, all right? So they kind of like cancel each other out. Isaac told us that when we had log base 7 of 7, automatically is a 1. Doesn't matter what that C is. If they're the same letter both times, it's automatically 1. Okay? All right, here are the law of logs. Yes.
These are my notes.
Yes, that's fine. Okay, here we go. These are the laws of logs. You're going to need them. I'm going to give you time to write this down. Tell me when you're finished, because then we'll talk about it. Notice we have the same base for all of them, log A. They have the same base. I can condense, if I had log M and I'm adding log N, I can write that and be math legal, to combine and just multiply the M and the N. So if I am adding two logs with the same base, it is the same as just multiplying. This should be somewhat like your laws of exponents. If I had two exponents with the same base and if I was multiplying them, it was the same as adding their exponents. We're kind of going backwards now. If you're adding two logs, you can just condense it to multiply. Here's the next one. If you want to call this, and here's an example. So I have log of 7, I'm adding log of 3. How in the world did I get 21? I multiplied the 7 and the 3. You can write this part down if you want. It's not something that you have to. The one at the top is the general one that you'll use most often.
Oh, that's an example under that one?
That's just an example of that one, okay? All right? Then you can call that one the addition rule if you want. We're going to do a subtraction rule next. Here we go. I'll let you write it down.
Oh.
This rule is, notice they have all the same base. We have base A. This one says that if I'm subtracting two logs with the same base, I can condense it and still be mathematically legal. You'll get the same answer, but you can condense it by dividing the two. So if we add two logs, it's the same as multiplying the insides. If I'm subtracting two logs, it's the same as dividing. Straightforward, I hope. Okay. Here's an example. You can write this down if you desire. So if I had log of 5 and log of 3, this is both log base 10, if you notice. To simplify it or to condense it into a smaller version, I can just write log of 5 over 3. All right, here is another rule. I'm going to let you write it down. Pause the video if you need it. This is not something that you would have intuitively known. If you have a log and they're the same base, notice I have an exponent. What do I do with that exponent and keep it legal?
Multiply by the 1?
Yeah.
Just stick it out front and multiply. Okay, so this exponent, this one's not intuitive like the other two, but it's useful. So I have that up there. It's just going to come out front and be legal. All right, so here's an example. I have log of 2 to the third, and I can just bring the 3 out. It's the same as multiplying. Okay. All right, now we're going to watch them. I want you to just watch this. Don't write this down. We're going to do somewhere you can write them down. If you absolutely want to write it, you can. But here we go. If I have this, and this was given to you, I want you to notice that all the logs are the same base. The instructions tell you to condense this. What can I do with the 2 in front of this log 2?
That's log 4.
I can put the 2 up here, correct?
Yes.
Okay.
2 squared
would be 4. Yes. So I am going to just write it like that, though. I'm going to bring the 2 up there. That was one of the...
Then you need to subtract log 3 from log 6.
Yes, so I'm going to move my way across, and it doesn't matter if I did it first, but what can I do to condense the addition?
6 times 4.
6 times that 4, which could be 24, or we can just write, for just simplicity so you know where I got it, I'm just multiplying them together. You with me so far?
Yeah.
How could I condense the subtraction? Dividing. So I'm going to have all this stuff over the 3, right? Mm-hmm. And at that point, if you wanted to put it all in your calculator, you could. This is 20. We said that was 4. 6 times 4 is 24. Okay. Divided by 3 is 8. And all of that would have been log 8.
Okay.
All right?
Perfect.
Number 1. What can I do with the 6 in front of the log 3? Log 3 to the... What about that 36 on the with the log 7?
7 to the 36.
Okay, log 7 to the 36. Notice how I always write my logs with cursive L's. I always, just because L's look like 1s. Okay, so I still have the addition rule. What am I going to do with the addition rule?
You're going to... So you can multiply the exponents?
Yes, I'm going to multiply the 3 to the 6 and the 7 to the 36. Watch how I'm going to write my answer. No calculator is necessary. I'm going to have 1 log, and I'm going to have a big parentheses with 3 to the 6th times 7 to the 36, and I'm done.
Really? Oh, so you don't have to do anything.
Don't have to do anything more.
Funky stuff?
Okay.
Stuff, right?
Okay, number 3. We have this 5 in front and the 3 in front, and we can take both of those and put them as exponents on top. So we will have ln 10 to the 5th minus ln 11 to the 3rd. Now this time we have a subtract. Last time we had an add. And so our rule said that when we subtract, we can condense it by dividing those two. So this is what we're going to do. We're going to turn this into ln 10 to the 5th over 11 to the 3rd. Let's move over now to number 5. Number 5. Notice we have x's and y's now, not just numbers. The rules still apply. We're going to put the 5 as the exponent and the 30 as the exponent. We'll have log x to the 5th plus log y to the 30. The addition here says we can condense it by multiplying these two things together. So we'll end up having log x to the 5th multiplied by y to the 30. There we go. Let's do number 7. Let's go to number 7 now. This has got the same idea. We just have ln's now instead of logs. So we're going to bring that 9 and stick it up there as the exponent, and 3 and put it up there as the exponent. So we're going to have ln x to the 9th plus ln y to the 3rd. The addition means that we're going to multiply, condense it together by multiplying. So we're going to go, it's going to be ln x to the 9 times y to the 3rd. And you really don't even need this multiply right there. We can just totally take it out. And there's our answer. All right, let's move on to a different kind. This time we're going to be expanding. Last time we were condensing, so we're going to go backwards now. We're going to actually try to make it bigger. And so we're going to start with number 9. Number 9, we're going to move that 5th power over there, okay? So we'll have a 5 log, we're going to keep the 12 to the 5th over 5. Now, what did we do earlier when we had a division? How did we get it into the division? Well, we had a subtraction. And so we're going to subtract these two. We just have to make sure that 5 stays with both of them. So we're going to have a 5, we're going to do an open parentheses. We're going to do a log 12 to the 5th minus log 5, okay? We're not quite done because we still have this 12 to the 5th, and we can expand that too. So we're going to bring down that 5. We're going to have a log, that 5 is going to come out front there. 5 log 12 minus log 5. Now, we could distribute this, or we can leave it as is, okay? Let's move on to number 11. Number 11's got a square root here. And that square root is going to become a 1/2 power. I'm actually just going to write it like that. We're going to have an ln 7 and 2 times 3 to the 1/2 power. Whenever we have the exponents and the multiply, we got to figure out which one we're going to do first. Am I going to separate this multiply right here into 2, or am I going to bring that out front first? Well, this 1/2 power is only on the 2 times 3. It is not on the 7, so we can't bring it out front. We're going to have to separate them by adding with that 7. So we're going to have an ln 7 plus ln 2 times 3 to the 1/2. And this part's done, so we can just rewrite ln 7. We're going to expand that by bringing that 1/2 out front. So we're going to have plus 1/2 ln 2 times 3. And we can expand this 2 times 3 because we can add it, right? We just need to make sure that that 1/2 is in parentheses. So we're going to have the ln 7 plus 1/2. We have ln 2 plus ln 3. All right, let's change the color so it's easier to see there. Okay, that's number 11. Let's move on to 13. All right, number 13, we're going to expand it. We're here multiplying, so we're going to add that. So we're going to have log x to the 4th plus log y to the 4th. And that 4ths we're going to put out front. So we'll have 4 log x plus 4 log y, and we're finished. Let's do the last one, number 15. At least the last one on this slide here. We have an ln. It's very similar to this one. This just had a log. So we're multiplying, so we're going to expand it out. We're going to have ln x to the 3rd plus ln y to the 4th. We did a plus, or we added because we were multiplying there. And then we're going to take these exponents and we're going to put them out front. So we will have 3 ln x plus 4 ln y. All right, let's do some more together. This is actually quite a bit of brain work here. We're going to use the properties of logarithms and the values below to find the logarithms indicated. Do not use your calculator to evaluate the logs. That doesn't mean you can't use your calculator. You just can't push your log button to do that. Okay, so we've got these 4 at the top, and we can use any part of those, or not all of them, to figure this out here. All right, so what we need to do is we need to figure out how log 64 can be made with, or just the 64 can be made with a 6, a 5, or an 8. So I'm noticing that 8 here 8 squared is 64. So I can rewrite this right here as log 9, 8 squared. We can use our rule that this goes out front. We'll have 2 log 9, 8. Now, the cool thing is I know that log base 9, 8 is 0.9. So I can plug in the 0.9 right there, and I'll have 2 times 0.9. At this point, you can use your calculator if you needed to. If not, then just do it in your head. 2 times 9 is 18. Since it's a decimal, it's 1.8. All right, let's start with number 19. Number 19, we need to figure out how these play out into the 49 and 4. I want to also bring to your attention that this is a base of 7, and we have something with a 7 to the something power, which will actually help. And we also have this 4 here, okay? That could help us. We're dividing here, and there might be a way to expand this. Let's see what we can do. So here we go. So we're going to expand it. I heard this. We're going to make this log base 749 minus log base 7, 4. We know this one is 0.7. But what do we do with the log 749?
7 squared.
It's 7 squared. Okay, so we can go log 7 squared. I heard that we wanted to move the 2 out front. 2 log space 7 and log 7 4. All right. Keep going. There's one thing that I hope you're going to remember.
2 logs.
The 7 can't that be
The
1?
7 becomes the log 7 becomes just
2 logs.
plain old 1.
So it's just log.
So this log's gone, and I have 2 times 1, which just becomes 2. And do we know what log 7 4 is? Log base 7 4. We know it's 0.7. And now we're done. We have no logs whatsoever. If you do not at this point, you're allowed to use your calculator. It's what?
1.3.
Very good. We're going to do these in terms of a variable. Notice we don't have log 11 is not a number now. They're A, B's, and C's. So we got to get this 10 to be something with an 11, a 6, or a 10. Does anybody have any ideas?
10.
The 10. I heard the 10. So we're going to make that log 9. 10 what? 10 times 10, 10 to the
10 squared.
10 squared. Okay, I agree with that. Okay. Then what?
Move the 2 over the front.
Move the 2 over in the front. 2 log 9, 10. Base 9, 10. Now what?
2 log C.
Now I want you to notice that log base 9 of 10, that whole thing becomes C.
So 2C.
So this is just 2 times C.
Okay.
Okay.
That's easier.
So 2C.
2C.
Okay.
And that's our answer.
That's your answer.
That's easier than the other ones.
Okay. All right, let's do number 23.
Yes, please.
Because we have 384. 384, we got to get it something with a 10, something with an 11, or something with a 6, or a combination of thereof. Is that
I think my brain just.
is that something? Is that 10 to the something power? Is that 11 to the something power? Is that 6 to the something power? Or is it 11 times 6 to the something power? We just found out that log base 8, 384, is the same as 8 times 6. Is that correct?
Yes.
Does that help us?
48.
Do we have a 6, and that's 8 squared, right? This is really 8 squared, correct?
Yes.
How can I expand that?
Put the 2 out front.
Bring the 2 out front,
So 2 log 8 to the 6, which is W.
plus, how do I get the plus? How does any of this, how does this last step help us get towards our goal?
Well, that becomes a 1.
This becomes a 1, and so we just have 2 plus something, right?
Log the 8
6
plus
is
W.
So this becomes 2 plus
W.
W. Okay. The trick on this one was figuring out what in the world is 384. So you just got to play around for a while with the 8, with the 6, with 11, with a 10, and all that stuff. All right, your calculator can only take the common log or the natural log, correct? And so you're going to have, if you wanted to take the log of another base, you have, like this one right here, you're going to have to do something else. Or that one. Or that one. Any base, we're going to have something. You have already memorized this formula. That will make your life easier. So if I wanted to have a log 5 here of something, I will just put it into this formula. I'm going to show you how to use it, okay? So if I wanted to find, this is log base 3 of 7, okay? We're going to use log 10 or ln because that's what your calculator has. You're going to use your calculators on this, yes? We're going to use log base 10 or ln. It doesn't matter which one you choose, what button you like best.
Wait, ln isn't log base 10. It's log base
It's not. It's log base e, but you'll get the same answer if you use either one of those because this will work for any of those bases. I'm going to use the log button instead of the ln button, but you can use whatever you want. So you're going to, if this is log 3, your change of base says that you put the u on the top and the c on the bottom. That means the 7 goes on the top and the 3 goes on the bottom. And you just type in your calculator, log 7. Be careful to close your parentheses after the 7 and then hit your divide, okay? So make sure that you close your parentheses after the 7. Otherwise, you'll get the wrong answer. All right? I got 1.771. Okay? If we're going to do log base 4 of 8, what are we going to have on the top? What are we going to have on the bottom?
4 on the top.
Careful. 8 on the top, 4 on the bottom. And so we're going to have that. Make sure, and I can use an ln, notice. If I wanted to use an ln, I could. You'll get the same answer as if you use log or ln, because this change of base formula will work for either one of them. It doesn't matter. You have that choice. In this world where everybody's telling you, when to get up, what school you have to do, I'm giving you a choice between ln and log. Freedom.
Should we worship you now because?
No, please don't. Please don't. You can say thank you though. So I got a 1.5.
Yeah, I did.
Okay. All right, so let's do number 25 and 27 together. You get to choose an ln or a log, I don't care. ln's smaller to write for those of you who want to condense your writing. I'm going to have log,
No, go back.
what over what?
11.
11 over log 5. The biggest trick is to make sure you just close your parentheses on that 11 before you hit your divide.
Did everybody else get 1.489?
Yep.
1.489, and it says to the 10, just the thousandth.
Isn't it 90?
1 point what? 4.
90?
I rounded up. 1.48.
This is only to the
4
top.
point.
1.490.
Yes, because you're going to need to round because it was 1.4898, and that 8
But it
makes that
only says
9.
round to the thousand.
Number 26 is the 51 or the 7 that's on the top.
51 is on the bottom.
So we're going to have log 51 over log 7. Just close that parentheses. That's the trick.
2.020.
I heard 2 point, how much?
Round up.
2.020.
Maybe I want to run down.
02, is it 020 or 021?
1.
Okay.
For the log.
This is what we did in this lesson. We saw the law of logs and we used it. Here's the first one. It says that if you add the same logs, you can multiply. If we're subtracting the same bases, you can divide. And if you have an exponent, you can just bring it out front. We use these to expand and condense, and we use the change of base formula with your calculator. Okay? I hope this has been helpful.